What if painting a custom logo like this could be done with just the click of a button? No stencils, no tape, no hand spraying. Right now, painting this logo would take a team of 5 people over 3 hours, upwards of $500 in labor and materials, and a stencil that costs $3,000. And that assumes everything goes perfectly. Many teams can't afford to repaint regularly, and most forego custom logos altogether. But for something so visible and high impact, it shouldn't have to be this hard. So we asked, what if it wasn't? And that idea sparked our senior design project. So come with us as we revolutionize field painting. When we started this project, we weren't just trying to build a robot. We were trying to reimagine what field painting could be. First, we wanted it to be easier, something a coach or event organizer could set up without a crew. Second, we wanted it to be more accessible, not just for big budget programs, but for anyone who wants to bring their field to life. And third, we wanted it to be more flexible, able to handle any design on any surface with minimal setup and no mess. This is Hugh, our solution to all of that. A compact, fully autonomous robot designed to bring logos and images directly to fields with speed, precision, and no stencils.
So how do we make this a reality? Firstly, we prioritize performance accuracy and efficiency, which allows us to achieve a one-size-fits-all solution to painting anything, anywhere. This creates a trade-off with our second goal of reducing technical complexity. This improves reliability and also simplifies our user interfacing. System simplicity therefore also guides material and parts selection alongside affordability, which is crucial to remove undesirable barriers for a wide group of user stakeholders.
So on our way, let's talk about how Hugh works for you. We use our guiding design principles in order to make the user experience as straightforward as possible. The user first chooses an image, then adjusts it to their desired size and location, then preps the robot. Hugh on the back end takes in your image specifications and plans out a path to follow and paint, without you having to do anything more than give your inputs.
In the meantime, let's talk about image processing. First, a user selects what colors they want to paint with, and our algorithm will classify each color to its nearest match. This circle now becomes completely orange. When you zoom in really close to a digital image, it is constructed by square pixels. Now that we classify colors, an edge can be easily detected by marking every 2x2 block of pixels that is not uniform in color. It is also much easier to tell a robot to go from point A to point B instead of following a curve. To accomplish this, we split lines into many dots, and then draw straight lines between these dots. This is exactly what we do for image edges, and at high enough resolutions they look identical. This leads to our next problem. Engineers have this annoying tendency to design systems assuming the worst. In our case, that would be our robot trying to paint from point A to point B, but finding itself completely lost. To correct this, we have an algorithm constantly trying to minimize both the angle and distance of error, creating a smooth trajectory. Finally, our last challenge comes from images that loop on themselves. Imagine an image that you cannot finish drawing without lifting the tip of your pen. To solve this, we mark our starting location, and at any time we can no longer draw anymore, we simply start over at the same point but going the other direction. Now, back to painting.
Though competitors exist tangentially in this space, our intended function as a fully autonomous image painting robot is unique. Among autonomous solutions, the main player, Turf Tank, paints only straight lines and have a limited number of available layouts. In prioritizing reliability, they limit their use cases significantly and therefore do not address Hugh's domain of dynamic image painting. Within the logo painting space, only assistive solutions built on top of human-initiated stenciling processes exist commercially.
All right, now it's time to talk about the robot. The big question is, how do we know where the robot is? We use 2 main methods to figure that out. First, our encoders on the wheels for a dead reckoning algorithm, and second, our 2 RTK GPSs, which give us both positional and rotational estimates of where the robot is. Now we combine that with something called a Kalman filter, which combines the 2 sensor datas into one, making it much more precise. We custom built this drivetrain using differential drive, which means 2 wheels on either side. And we chose this over 4 wheels because it allows us to have 0-point turns, which allow us to move in any direction we want and get much more precise painting accuracies. Our battery is 20 milliamp hours long, which means we have around 10 hours of continuous painting time. We only really need to charge the battery every 2 weeks. The paint sprayer sprays at 0.14 quarts per minute, which comes out to about 7 minutes of continuous paint time, but we never really reach that number.
Our user interface is designed for simplicity of use and mapping accuracy. Users can process their image, visualize their image, start and stop the painting process remotely, and track their progress with our live plotter.
If how the user interface works, let's do a quick demo. The interface itself is a pure Python executable. On the left is our main interface, and on the right is a plotter used for tracking robot movement. 2 nodes, a GPS data consumer and a waypoint transmitter, are used to facilitate communication with the onboard compute of the robot. To begin, we can choose an image and use our image processing pipeline to convert it directly into waypoints, which can then be transmitted to the robot remotely. As we can see here, our P appears nice and big on our map. Alternatively, you can also select a preprocessed series of waypoints for repeatability, which we'll do now. Here we have our apple instead. Once loaded, the user can transform the image however they like, by rotation, or also scaling. Once the desired image has been arranged, the user can initiate the painting process by sending these waypoints over our subnodes to the robot.
From the car to the field, the robot only takes 10 minutes to set up. Generally, the environment is unaffected by our environmentally friendly paints. The robot only weighs 50 pounds, and it takes 20 minutes to paint a full NFL-sized logo.
Now, let's see it in action.
It takes $3,300 to build the robot, which is about the size of an average stencil. Except our robot can paint infinitely large and infinitely many different logos, and the only recurring cost is paint.
Achieving a low cost of approximately $3,300 per robot was a strategic priority, ensuring affordability and accessibility to a wide range of potential clients, including sports teams, schools, and event organizers. We offer flexible rental services, allowing clients to use our robot without significant upfront investment. And this model is particularly attractive to one-time or occasional users, such as for special events or seasonal sports. Our rental packages include trained personnel that can operate the robot on site, eliminating any operational burden from the client and guaranteeing quality results. This allows us to establish recurring revenue streams from event planners and venues, while also achieving rapid market entry and scalability due to our low building costs.
We are Hugh, and we're revolutionizing field painting. Thank you for listening.